Welcome to another video. Today we're going to look at Edge AI. The idea of Edge AI is that we have a neural network or some kind of artificial thing, artificial network, and that we implement it on a small embedded controller. Well, I've made a small tutorial for this. In this case I'm going to demonstrate how we would the tiny machine learning kit from Arduino. I'm gonna show you what the kit is. So it's this. It's got a NanoSense 33 with a small camera and a little interconnection board. And you can buy this for, well, apparently you have 50 euros, but I don't know if it's cheaper anywhere else. Anyway, you connect everything and you can implement a neural network on this controller. And today I wanted to show you how that's done. And I start at all the links I'm going to put in a file in the comments. So basically I made a Colab file. It's based on somebody else Colab, to be honest. It's based, this part is in large parts based on Daniel Moser, his article. But that's basically the first part. Is basically about learning the network, and we're going to use the standard, the hello world for neural networks, which is basically digit recognition. So it's not that exciting. Basically we've got two parts. We've got the part in the Colab, which is Python based, where we train the network, and if we have trained the network, we're going to implement it on the Arduino. And that's C based. And the Arduino will execute the model. So you cannot train it on the Arduino. The Arduino is too weak to do that, at least for this bigger model. So we'll do it on the laptop, and then we implement the model on the Arduino. So this is the part where we train the model. So and I'm just gonna let it already start because it's going to take some time, but I'm going to do it real time so you will see what's happening. So runtime, execute everything, and what this basically is going to do, there's a lot of code in this. This is an IPython file. So basically it's now executing, for instance, this code. And it will continue executing all the other code, but in the meantime I can explain already a little bit. So this is the database where with which we're going to train the neural network. It's a MNIST beta database. It's real nice. It contains 60,000 images of handwritten digits. And we're going to train a neural network with it. And the neural network, there's some, well, here you see basically all the shape of the numbers in that data set from MNIST. Here you see it a little bit differently. But what we're basically going to do, and I'm not going to explain the whole file because this whole thing, because it's relatively self-explanatory. But basically we're going to make a network like this. Is this the best type of network for this problem? No, probably not, but it's relatively easy. So this picture is basically the idea. So you've got 28 times 28 pixels. So a lot of pixels, something like 794 or something, and then we connect them all to neurons, and those neurons are all connected to an extra layer, and the output layer there we're going to see is the 0 or 1 or 2, etc. This picture is in this example they have 512 nodes and 512 nodes. This works pretty good, but it doesn't fit in the Arduino sense, so we have to make it smaller. One way to do is just take less neurons. I could also make other changes, but to keep it simple I just took less neurons for this first and the second layer. So 112 neurons for this and 112 neurons for that. Then we're training, we're building the network, and it's all explaining. Here you see how big the network is, 397 kilobytes of parameters, trainable parameters. And that needs to fit in the Arduino, and that's also the reason why we cannot make it much bigger. Well, this is the training step. Here you see that's already trained. That's nice. And then we can see here how accurate it is. and it's 97% accurate. Well, yeah, on the test set of this, but when I upload it in the Arduino sense, I think the accuracy is actually a lot less. But okay, it's nice as an example. Then, if we have the model, and this model we can here in this environment test, and we can do all kinds of stuff, but we want to create a TensorFlow Lite model to download it in our Arduino. And it's surprisingly easy. It's this step. There we make a model, and the model is then 408 kilobytes, which still fits in our Arduino luckily. And then we convert that model to a .h file. So people who are familiar with C programming know this. It's just a file, an H file, so a header file. And this header file we download. That's pretty easy to do. You open this one, so you can copy this whole file also, and then you can download this header file. And we can put this header file in our Arduino environment, or in the directory where we have our Arduino file. The Arduino file is, I've put it on a GitHub, and again I will put all these links in the comments. But here there's the Eno file, and I've also put here the model, but basically you can make the model yourself. This is a test document with some numbers in it. So here, this is the Arduino file. I opened it already, downloaded already. That's this one. And the model file, it's pretty funny. It's actually just a huge array with numbers, with bytes, I think. Yeah, with bytes. So the whole training, what we just saw, etc., etc., it's converted in this large array of numbers. Then we're gonna upload it, and I'm gonna show it because it will take a huge amount of time. This is really the first time I played with this around. I was thinking nothing happens and everything is wrong, but it can really take a long time. This especially because it's a large model. It could be that when you really want to download it, that maybe you have to reset your Arduino by double-clicking the button on the Arduino. I don't know if it's needed right now. We'll see. It's getting close to finishing its compiling. The first time compiling it goes quicker. So now it goes slower, I mean. So now it's already getting, yeah, okay, it succeeded. I don't have to reset my Arduino or to put it in programming mode. So it's just uploading now, which is nice. And okay, uploading, and you see already that this is really like not your normal a piece of cake with Arduino, because this is all this stuff is much bigger, much heavier, much more data. But then again, the processor, which is ARM Cortex M4 actually, is also a lot heavier. So now we're gonna see what's happening. This was my previous one. This is after the startup. So this is what's happening now. And basically it says, well, I connected everything and it seems to work. And he says, press return to start the capture. And we're going to do that. And I've made in this file like a monitor to translate it to so that you can see what the camera actually is picking up, because the field of view of the camera is really low. In this case, I've printed out the numbers in the test set. It's also in the GitHub file. There's a doc. Here you see this doc, and you can print it out, and then you can test it. And I've put the paper approximately 20 centimeters away from the camera, so pretty close by. And you see that in this case, this 2 is actually pretty good recognized, which is nice. Now I can see if I can pick another number, and it's a little bit, I have to each time press enter to see what I'm doing. Oh, apparently there is something maybe a little bit higher. No, lower, right? It should be lower. Let's see if I can find a here we've got the 9. Well, it's actually already pretty good centered, so maybe a little bit down. again pressing enter. Yeah, it's pretty good centered. And here you also straight away see the limitations. This 9, which I think is a 9, it's a little bit strange 9, but he says, well, I think it's a 5 or a 7. And this is really the limitations of this model. Apparently it works, but it's not that good. And it's not some error of the Arduino code or something like that, because I also I've got in this Arduino file, you can there's also a logging. You can put it on true, and if you put it on true, I'm not going to do it right now, then you can, it also really spits out all the numbers of this picture, and and those numbers you can put again. Well, you need to actually write a little bit of code, but it's not a lot. You can put it in here somewhere and test this model, and it's one-on-one. So the fact that it's sees this 9 not as 9 is disappointing, but not the fault of the Arduino. It's actually doing exactly what the model told him. So this is a real quick introduction in implementing a machine learning model on an Arduino Sense. So this model basically was implemented, and we used the camera to really see if it works or not. And it worked really well on the 2, and it worked pretty bad on the 9. And a different number will work a little bit better or a little bit worse, etc. I hope you have fun. Bye bye.